Class 6 Mathematics, Chapter 5 Natural Numbers and Whole Numbers. Children, you have already learnt about the properties of whole numbers for addition. Here, we will learn about the properties of whole numbers for subtraction. First, the closure property. If x and y are two whole numbers, then x minus y is not necessarily a whole number. For example, here the value of x is given as 5 and that of y is 2. So here in this case, x minus y, that is 5 minus 2 is equal to 3. Here 3 is a whole number. But in the second case, the value of x is 10 and the value of y is 15. Now if you subtract x minus y, you get 10 minus 15, which is equal to minus 5. Now minus 5 is not a whole number. So for closure property, x and y, when two whole numbers are given to you, not necessarily that the answer will be a whole number also. So whole numbers are not closed for subtraction. Commutative property. If x and y are two whole numbers, then x minus y will never be equal to y minus x. Understand this example which is given over here. The value of x is given as 8 and the value of y is given as 10. Now, if you subtract x minus y, we get 8 minus 10. That is, putting the value of x and y, we get 8 minus 10. Now, 8 minus 10 is equal to minus 2. But if we subtract y minus x, now here the value of y is 10 and that of x is 8. So y minus x will be equal to 10 minus 8, which is equal to 2. Now are these two same? Minus 2 and plus 2, are they same? No. The difference is the sign. One answer is minus 2 and the other is a plus 2. So both are different. So here the commutative property is not satisfied. That is, x minus y will never be equal to y minus x. The third property, associative property. For any three whole numbers given to you like x, y and z, subtraction does not satisfy associativity. Which means x minus y written within the bracket minus z will never be equal to x minus y minus z written within the bracket. See this example over here. Let the value of x be 15, y 10 and z 7. For the first case, x minus y within the bracket minus z. Now within the bracket when you are writing x minus y, that is 15 minus 10, and outside you have minus 7. So 15 minus 10 will give you 5, minus 7, the answer is minus 2. But in the other case, now x minus y minus z within the bracket, this will be equal to 15, which is the value of x, minus within the bracket 10 minus 7, that is y minus z. Now when you subtract 10 and 7, you get 3. So here in the next step, 15 minus 3 will give you the answer as 12. Now in both the cases the answers are different. In the first case the answer is minus 2, whereas in the second case the answer is 12. So here the associative property is also not satisfied for subtraction of whole numbers. Distributive property. For any three whole numbers x, y and z, x into y minus z within the bracket will be equal to x into y, that is when you're opening the bracket, x will be multiplied with y minus sign again x multiplied to z. For example, let the value of x be 2, y 3 and z 1. Then according to the rule, if we are opening the bracket and multiplying, that is, in this first case you just see 2 into 3 minus 1 within the bracket. Now 3 minus 1 is equal to 2. So 2 into 2 will give you the answer as 4. This is a simple sum. But if you are trying to satisfy the distributive property over here, so now if I open the bracket multiplying 2 and the other two numbers which is present inside the bracket. So 2 into 3 minus 2 into 1. So 2 into 3 will give you 6 and 2 into 1 will give you 2. So 6 minus 2 will give you 4. So here you see in the first case also your answer is 4 and in the second case also your answer is 4. So distributive property is possible for whole numbers. Existence of identity. For any whole number x, x minus 0 will give you the answer as x. For example, 5 minus 0 will be equal to 5. But if I try to write 0 minus 5, will my answer be only 5? No, my answer will be minus 5. Here 0 minus x is equal to minus x. So for subtraction, no identity number exists. That is, there is no existence of identity, leaving 0 only, because 0 minus 0 will always give you the answer as 0, which is a whole number. The sixth point, existence of inverse. Since subtraction for every non-zero whole number does not have identity number, so its inverse does not exist. Now one example from exercise 5b has been solved over here. That is question number 5. It is given in this question that 12 into 9 minus 6 within the bracket will be equal to dash equal to dash. Let us solve this. So first of all, 9 minus 6 within the bracket will give you 3. That is 12 into 3, which will give you 36. In the second step, when you are using the distributive property, so 12 into 9 minus 12 into 6. So 12 into 9 is 108 minus 12 into 6, which is 72. So 108 minus 72 will give you 36. Now which property is used over here? This is the distributive property which is used over here. So we can see that these two are same and the distributive property is always applicable for the whole numbers for subtraction.